I'm Todd Latanzi. I'm responsible for strategic accounts at Ciclu. And what we wanted to do today was a couple things. One, share a bit about the overall millimeter wave market, what the solution is that we have to offer, and then we'll spend some time in the second half walking through one of the tools that we have that really makes it pretty simple to actually take a neighborhood, for example, and design a complete network. We'll do a small example just in the interest of time, but talk through how that scales up to much larger neighborhoods that are pretty typical for us. So with that, let's go ahead and get started. We'll skip this first slide. So one of the things that I find when I'm talking to a lot of our operator customers, and hopefully these things resonate a lot with you. I mean, we all hear all the time about Gigabit, the demand for Gigabit. As a matter of fact, I saw an article yesterday. I'm sure everybody's familiar with Google having deployed Gigabit service into a number of different areas around the United States. They actually announced yesterday that they will no longer offer, in all the markets, they have two offerings. One is obviously Gigabit, and the other is 100 meg. They announced yesterday that they will no longer offer the 100 meg service, with their thought that everybody's really starting to get a lot more interested in Gigabit service. So it'll be somewhere. We see that a lot too, right? I mean, think about all the different streaming services that have launched over the past year or something. Most recently with Disney Plus and Apple TV Plus, right? That's certainly the way things are going. And as the resolution increases and we start streaming more and more 4K type content, we see our customers look at more cloud gaming kinds of platforms and lots of other different use cases. The capacity need is certainly only going to grow. So, traditional operators, what we've seen, they're looking for ways to get into the market faster, stop having customers walk away from competitive offerings. Many times it's the cable company in a particular neighborhood or a particular area, because they can't maybe get fiber built fast enough. And so one of the things that you'll find with us is we're a solution that's very complementary with fiber. We don't really compete against fiber. There are certainly good use cases for both technologies. And so what we'd like to do is present a case today about how millimeter wave to deliver Gigabit is a pretty effective platform to get you into the 5G game very quickly. So with that, a little bit about, for those that maybe have some wireless experience in the past, traditionally operators have deployed wireless customers in the unlicensed 5 gigahertz band over here on the, just draw your attention to the bottom left here. Not a ton of bandwidth, usually pretty noisy, even in rural areas, because you're competing with things like your in-home Wi-Fi access point, and a lot of other things that use the 2.4 and 5 gigahertz bands. Most of the time we see customers in the sub 50 megabit range for a service deployment. Maybe 100 meg tops, but those tend to be customers that are a lot more closer in. It's a lot less deterministic of an offering. But it certainly is prevalent. The performance isn't quite there though, and not really a way to get into speeds that are much higher than 100 meg. So that's one of the advantages of millimeter wave. You can deploy highly reliable, actually fiber-like reliability using millimeter wave technology and do it very quickly. It's really just a matter of hanging a radio on a structure that already exists to serve a customer from an access point perspective. Could be a telephone pole that's in the neighborhood, could be a light pole, could be the side of a house. I'll show you some pictures of what that looks like coming up. And the good news is also you don't have to acquire any spectrum. So there's no auction, no cost to the spectrum. You could literally take our 60 gigahertz technology today, walk outside and deploy it without buying any spectrum. And because the beams are so narrow, it's interference free, and we'll talk about that coming up. So millimeter wave really has a tremendous advantage over just about any other wireless technology to get gigabit service delivered to subscribers, whether they're single-family homes or businesses, multi-dwelling units, a whole host of other use cases. So why does millimeter wave work so well? One is it's got a tremendous amount of spectrum. In order to get that gigabit capacity, you need a lot of spectrum, and that's how the 60 gigahertz band was designed. There are multiple channels that are about 2100 megahertz wide, as opposed to a 20 megahertz channel. So you're you have 2 orders of magnitude more spectrum available than you do in the 5 gigahertz band. The other huge advantage is because you have such a narrow beam width, unlike 5 gigahertz, as you can see over on the right-hand side, that's got a very wide RF propagation pattern. Not surprising, right? That's what we all enjoy about Wi-Fi access points inside our own home, not having to have too many of them. The same is true when you deploy fixed wireless using unlicensed 5 gigahertz. It's also very wide. Good and bad. Covers a lot of area, but also becomes very noisy to do that, and oftentimes in a more dense environment, you struggle with self-interference or interference with from another operator. Not the case with millimeter wave. Millimeter wave has got a very, very narrow beam. So despite the fact that the spectrum is unlicensed, you don't have to worry about any kind of interference. It really is interference free. You can almost think about it, despite the fact that what we'll talk about in a residential environment is a multi-point device. You can really almost think about it like individual point-to-point connections between the base station and each home or each business. So easy to deploy, interference free, and you don't have to buy any spectrum. So it's a really good choice. Other advantages. We've all experienced, here where I live, a customer of one of the MSOs. I've experienced this ability for them to just dial up the bandwidth periodically. I've never paid for more bandwidth over the course of however many years I've been a customer, but I started out with maybe 100 meg, and today, over the course of time, they've increased that periodically, and now they're delivering 300 meg to me with no increase in cost, and they didn't send anybody out here to do it. That's a difficult proposition to beat unless you're a cable provider or you have fiber. There is no other wireless technology other than millimeter wave that can do the same thing. And so what we see a lot of times is customers maybe start out with 100 meg service, or have a lot of their customers more interested in 100 meg or a couple 100 meg, something like that, but then have the advantage of being able to use the exact same radios that you're hanging on the house to scale up to gigabit without actually rolling a truck out there ever again. So you can do exactly the same thing that the MSOs do. You can do exactly the same thing that you can with fiber in terms of being able to dial up whatever service offering you want remotely, or start out with a gigabit to begin with. For those of you who follow all the 5G buzz in the news, the technology is absolutely part of the 5G spectrum. There's a lot of different things out there that you'll hear, whether you're talking about mobile 5G or whether you're talking about more fixed wireless 5G. But millimeter wave technology is part of that. In fact, if you followed what AT&T and Verizon have done here in, they're probably pushing close to 20 cities now. When they talk about their 5G broadband fixed wireless service to the home, they're using millimeter wave spectrum to do that. They're using part of the spectrum that they bought and acquired that's a little lower frequency, but you can deliver the exact same service with the higher frequencies and do it in a manner that's completely free of having to purchase any spectrum whatsoever. So big advantage, and really the only choice outside of if you're at least in the U.S. with one of the 2 big operators like AT&T and Verizon. So how do you get started on all this? So let's talk a little bit about what some of the building blocks are in order to start from scratch. Start from a neighborhood where you don't have service at all, or perhaps whether you have legacy copper service and scale it up to go deliver gigabit without having to trench in the yards or dig up the street, or if there's any sort of telephone poles that you might have access to, you can avoid having to go hang aerial fiber as well in this sort of situation. So we'll start with the middle pane here, and then we'll talk about the two on the left and the right. Secondly, really the backbone of the solution that we have to offer today is a multi-point radio. A little bit hard to gauge the size in this picture with no real reference, but the easiest way to do that is this radio on the right here. Hopefully you can see the mouse moving a bit. Is the size of a smartphone. It's literally the size, it's about an inch taller than an iPhone 10 or 11, for example, or maybe about the same size as an iPhone Max. It's literally that size, that width, and that height. So it's a very, very small footprint to go hang on the house. That's important because what we run into a lot is people, and not surprisingly, being very interested in the aesthetics of what you go hang on their house. And so if you think about this as in comparison to a DirecTV or a dish satellite television antenna, that's a big 18-inch dish, just imagine hanging something the size of your smartphone on the side of your house to deliver gigabit service. Once you have that, once you show somebody or talk to them about what the size of the equipment is you're going to put on their house, that becomes a completely it's a non-issue at that point because it completely disappears with the other things that are on the house. And I'll show you some examples here coming up about with some customers that have actually mounted it. So this radio on the right is what actually mounts on the side of the house to deliver service. And then the access point side is the radio to the left. Think about that as a paperback book size. It's also pretty small. Where do you put those? You typically put those either again on a home, and we'll talk about the concept of a hub home here coming up, or on telephone poles. And really what drives the decision there is, do you have access to vertical assets within that neighborhood, or are there any vertical assets in that neighborhood other than the home? So no difference really from a architectural deployment standpoint, what you're hanging on. Really just comes down to what do you have access to. So the middle combination is what provides the access side. And then you either supply fiber directly into the radios, if it's available or if it's close by, or if not, then typically what we see is customers pair that with one of our point-to-point radios. More often than not, in a larger size neighborhood, and depending on the service offering, take rate, and so forth, oftentimes customers will use our 10 gig point-to-point radio to feed the entire access side. And I'll show you what that looks like in a design coming up. It's also a very small footprint. This picture here is a 1-foot antenna. And in a typical neighborhood, you don't need anything bigger than that. So you're really not talking about putting physically large devices inside the neighborhood at all. Pretty simple to deploy, then to deliver the backhaul bandwidth into the neighborhood, and then provide the access side. Where we'll spend some more time a little bit later in the presentation is an equally important piece to the entire solution, which is our Windy software design tool, and it's really the thing that gets you from Google Earth to the gigabit design here very, very quickly. Frankly, you can't really. It's difficult, having done it before. It's difficult to go do a design without having some sort of tool to help along with it. So it essentially goes in and lets you automatically select where all the homes are, automatically detect where the homes are, and then you simply start creating paths either manually, or you can automatically create paths between the homes to then help with the design. So we'll actually log into that here coming up in a few minutes. So you can see what that looks like. So when we talk about a single-family home deployment, what are we really talking about? Obviously a picture of a neighborhood there. It looks like a lot of neighborhoods, more or less trees in some. One of the other things that I'll mention to you as we start talking about this is the question I get commonly is, hey, I don't have a lot of neighborhoods that don't have trees in them. And I would tell you to that, it's not something you have to worry about. It's pretty rare when we go into a neighborhood with a customer that it used to be a cotton field, for example, and now there's a lot of houses there. Those are great, and those are really, really simple to deploy from a wireless perspective, but it is by no means the most common situation. And in fact, the neighborhood that I've picked, it's one that we're working on with another customer to show you, is actually a pretty heavily treed neighborhood, and so I'll show you some of the ways that we work around the trees in that neighborhood to make that work. But by no means do you need to have a wide open neighborhood to make the solution work or be cost effective to do it. So let's jump to the next slide. I'll use this picture to describe what was on the previous slide a bit. So typical kind of neighborhood. And what you start to think about in the neighborhood is how do I now go cover all of the homes in the neighborhood? And there's a couple of ways you do that. One, just start identifying what are, number one, either the optimum hub homes. So let's assume for the minute that there are no above ground utilities and you don't have any access to street lights or things like that. So in that case, a very common or the most common way to deploy the wireless in the neighborhood is to take those paperback book size radios and hang them on the side of the house. Depending upon what you can see from that house, you might need 1, 2, 3, maybe 4. I'll show you an example of a customer who's got 4 to get 360 degrees of coverage in their particular deployment. From there, you simply just start fanning out, just like it shows here, or cascading out to other homes. So you'll have your primary hub home here in the top, and then start looking for what other hubs make sense to use to provide the coverage that you want, and then continue just to cascade through the neighborhood. The alternative is, and I've got a customer that's doing this now, that's an electric co-op as an example, is to use poles. Could be that already exist. Could be light poles or street lights. It could be wooden telephone poles. It doesn't matter as long as you've got line of sight between the pole and the home. Then it doesn't matter, as you can see here, and it works exactly the same. You start choosing a pole here, maybe a pole over here, and work through the neighborhood to ultimately provide the coverage that you want throughout the neighborhood. If you don't have access to those poles already, typically, and you don't have a good solid relationship already with the owner of the poles in the area, what we typically find is that becomes it typically becomes one of the more challenging issues to resolve, is to get access to the pole, because typically somebody will want you to pay for that and pay for the attachment rights, and sometimes that discussion can go on for quite some time. Whereas if you go to the homeowner and say, who already wants gigabit service, hey, if you'll let me put a couple of small radios on the side of your house, I'll give you $5 or $10, $20, something like that. Or maybe even free service for the life of the as long as you're there, or for the life of the home. Oftentimes, the provider makes that transferable so that the next person that comes into the house has the same deal, and it makes it very simple. We have yet to find a homeowner that's not interested in that kind of a deal. If they are interested in your service, and they see the size of the radios, again, think about it compared to a direct TV antenna, which is substantially larger. They typically take that deal pretty readily, and so it ends up being a lot easier, a lot faster to negotiate with that homeowner. So then, how do you get that backhauled? Again, doesn't really matter. Maybe you have fiber running down a parallel road here, Maybe there's a fiber pop close by, and so maybe you trench or hang fiber to the first hub home in that neighborhood, as shown here in this blue line will indicate a fiber connection. If you don't have that option, or maybe it's too far away, or the economics don't make sense for whatever reason, then just shoot it into the neighborhood. Use one of our point-to-point radios to do that, as shown here. The solution is designed, when you design the solution, you design it to have the same reliability as fiber. So, there's sometimes some perception out there of, hey, if it starts to rain, the service goes away, or if it's snowing like crazy, I'm not going to have internet service. Those are absolutely fictitious kinds of things. And so while with millimeter wave you do have to think about rain and where you are, you consciously design the network to account for that, so that you always have a very highly reliable and highly available network that absolutely rivals fiber in every way. The other thing I'll mention, I get this question from time to time, is can I do voice? Is voice a problem over video? Absolutely not. I have customers today that are delivering triple play service over millimeter wave with absolutely no problem. In fact, the latency over the millimeter wave link is actually less than the latency over fiber. So there's absolutely no problem delivering any sort of latency sensitive application over millimeter wave. So what does it look like? This is an example, a couple of examples actually. The one on the left is a hub home. This particular customer used a fairly tall pole. A lot of times what you'll see is a shorter pole where the radios are just peeking up over the top of the eave of the home. But these guys needed something a little bit taller. But you can still see that even though there are actually 5 radios here, this bottom one is actually providing backhaul. It's a very compact design for them. And then on the right, this is actually a little bit larger. One of our original subscriber side or CPE radios that's there shown hanging on that. So you can see it relative to the size of the downspout. It's a very small footprint. We've even had people, the same customer who was deploying these radios actually had one customer who asked them to mount it on a J-arm kind of in some shrubs. It was peeking up over some shrubs at the ground level. Most of the time we see people hanging up on the side of the house like this or on the eave, but certainly it doesn't matter where you place the radio relative to the base station. As long as you can see it, you're in good shape. And that's really the only constraint. So as you can tell, they're very small. I'll show you some pictures coming up of a business deployment that we did that maybe gives you a little bit better sense of what something like this looks like as compared to a direct TV antenna. Oops, wrong way. So let's shift gears for a minute and talk about the same kind of an application in kind of a Main Street business area. So exactly the same concept. Think about the businesses that are maybe in your downtown area, maybe where you don't have fiber, maybe in an adjacent town, but anything, right? The local insurance agent, any of the municipalities. We've even got customers that are interested in not only providing gigabit broadband, but then also setting up public Wi-Fi hotspots. Maybe they close down part of the main street for some sort of festival during a few times of the year, and they want the public to have access to Wi-Fi. And so we'll see Wi-Fi access points deployed using millimeter wave as a backhaul, or in many cases, a lot of our business centers around video surveillance. So if there's interest from some of the public safety entities about deploying cameras in certain parts of the town, that's also a very common use case for millimeter wave, and can also be used to deliver broadband to other parts of the municipality there. But jumping back to more of a traditional business customer in the town, I think you'll agree this picture looks very similar to what we looked at in terms of the single-family home. Very simple to deploy. Here, instead of using street furniture, oftentimes customers will mount on the roof of a building downtown. We've got customers that are doing this right now, as a matter of fact, and they'll use a small non-penetrating roof mount with a small pole that sticks up, so it's just above the lip of the roof, and then start distributing gigabit service to a lot of the customers or a lot of the businesses in the downtown area. We had a pretty interesting use case a while back with a customer called Jade Communications out in Colorado. They actually had fiber in the town and unfortunately experienced a fire that burned a lot of the infrastructure, and so it left their downtown area without service at all. And as you can imagine, that was not going to be a short-term recovery for them to restore service. So what they did, I think originally they started out doing this thinking it was going to be just a temporary measure, was deploy point-to-point links from a tower outside the town where they had fiber that was still intact into the town. There was a small structure they could mount on inside, directly inside the town. So they delivered that fiber bandwidth using a point-to-point connection. From there, on that same tower, they used our multi-point radios, as you can see here, to then start distributing service to the individual businesses. And this is actually the picture on the top here that I think is a good one, that shows you the size of the millimeter wave radio as compared to a traditional DirecTV antenna. It's substantially smaller. And then if you look in some of the other pictures, you struggle to actually see the radio, right? Look at the one mounted on the chimney, for example, or peeking up over the edge of the roof. If you're not out there actively looking for it, you're really not ever going to see it. And in fact, oftentimes when you've mounted it on the roof like this, unless you are very far back from the building, you can't see it at all. We've got customers that do the same kind of thing in apartment complexes where they mount it in the parapet right in the middle of the building, and you can't see it at all from the street level no matter what you do. So the aesthetics is a very important part of what our solution offers, because we understand from the deployments that we've done that that's a key piece for the guys that go out and deploy it. So let me pause there for just a minute before we jump into the design tool, and I'll show you how to actually go from a blank sheet of paper to a whole network, and ask if there's any questions. And just remember, if you don't mind, raise your hand, or let me see if anybody's chatted something in here. Nope. Okay. And I'll be glad to unmute you to let you ask your question. All right, well, let's move on. Okay, so how do you get to the point where you start with a neighborhood? And we're going to use a neighborhood that we're working in right now, and pick part of it and go do a design. So let's kind of talk at a high level about what the steps are to do that. So the first step is we're going to go into a tool that looks very much like Google Earth. We're going to select a neighborhood, and then what we're going to do is automatically detect the homes in the neighborhood, and then we'll start making the connections. The neighborhood that I'm going to show you is a small neighborhood, so we're going to just do this one by hand, but I'll talk about what you can do in a much larger neighborhood using LiDAR data that's, for the most part, freely available throughout the country, to go in and strip out a lot of the connections that clearly go through trees once you set up the automated tool to make the connections for you. We'll go in, we'll choose where our hub homes are, and then we'll have the tool automatically generate a complete bill of materials for you to then use for the deployment. So I'm going to pause for just a second, and then I'm going to switch over to my web browser. Okay. So hosted on our website, planner.sickly.com, is our Windy tool. So it's cloud hosted, so you can get to it anywhere. You have to be a registered user or website to have access to it. Easy to do. If you're already a Sickly partner, you have access to it already. And if not, it's something that we can very easily allow you access to. So I'm just going to log into my account here, and I've already set up, you'll see some of the other projects, but I've already set up a folder just for our purpose today. And so what we're going to do is go in, we'll create a new project. We'll call it Gigabit to the home. And for the most part, you can pretty well leave all the defaults as is and just get started. One of the things that I'm going to do here is just go make one change, actually two changes. So one of the things in this screen that you do is you can set up what distances that you'd like to use for what product, and the tool will automatically figure out the rest. So let's just say in this case I'm going to use 300 meters. Our MHBU is our multi-haul point-to-multipoint device, which is the access equipment. And then I'm going to say anything over 600, between 300 and 600 meters, or in this case we'll say, we'll just leave it at that for now. Actually, we'll change it maybe to 1500. We're going to use one of our 8010s with a 1-foot antenna, and that's all we've got to do. We'll come back to why I did that here in a minute. And then we're going to go hit create. And now we've popped into a Google Earth view. All right, so I got a question. So Kevin, let me unmute you and go ahead and ask your question.
So can you do this if you have a CAD drawing on a new neighborhood that has not been designed, but it is under construction?
Yes. So, I mean, if you have a Google Earth KML export, you can import that in. And the other thing, actually, I'm going to switch to the roadmap view too. That's a great question, because I'm going to show you, I kind of picked this neighborhood on purpose. Let me get to the neighborhood. All right. So this neighborhood is actually, and Kevin, if I don't answer your question completely, just raise your hand back up if you don't mind, and I will we'll take another crack at it. This neighborhood, I know, based on when the satellite imagery was taken and when the Google guy drove around, there were some houses that were constructed, and I kind of purposefully picked this to show you a couple different things. So we're going to start with this neighborhood. I'm just going to pick a small portion of it right now, and what we're going to do is we're going to zoom. We're going to just select this area for now. And then what I'm going to do is I'm going to go in and click on house detection. Give it a second or two. All right, and you can see that it has tagged all the houses in that particular area. Now let me flip to the satellite view here, because when this image was created, and when this image was created, there were more houses built. So, you know, sometimes we'll see even just pads, right? So hopefully, Kevin, this might answer your question, where now what I'll do is actually just very quickly, I'll go in and select locations, and then I'll just tag my locations. So, for example, if you don't have the homes already built, but you know there's lots there, then this is the kind of thing that you can do. You can go in and tag them individually. And we'll get that one. I think we'll be done. So I purposely picked this neighborhood to kind of show you the difference there between those two, so you could get a sense about the automated version or the manual version. The same works anywhere. I'm going to delete this polygon just so we're not looking at it all the time. And you know, I could have chosen this whole neighborhood. I could have chosen this whole entire area, you know, and done the same thing with it. Have it automatically choose the houses. Now, to start with, let's just assume that this particular operator's got fiber, you know, running down this road, and you know they want to stub it out to this house. So we're going to make this house a POP. So basically, that's going to say, all right, this guy with the lightning bolt here is the one where fiber or the bandwidth, the backhaul bandwidth is available. So from that point, I'm going to show you the manual way to do it first. This neighborhood is it's simple enough. And so really what we're going to do is just start making quick connections between these houses where we have line of sight. Sometimes I might have to do something like this where I'll move, you know, for example, the node over to this particular side of the house because I can't go straight through necessarily with that tree there. So how do you do that? Well, it's really simple. Just start making the connections between the homes. And I'm going to do this real quick. And then now, as you can tell, there's a number of trees in the neighborhood. So for example, I can't go straight from there to there. Distance-wise, it's fine, but I've got stuff in the way. And so to accommodate that, we'll now start kind of making connections in this type of a manner, where we go and kind of walk around the curve here with some. Whoops. In this case, then I'm going to go back down to this one, and I'm going to go grab that house, and that one, and what else am I going to do? I'm going to grab these down here. And then we'll come back up, and I think we're going to use this guy as another hub, and we'll come down to here. And we could grab that guy that way, probably him there. And we'll finish up up here on the top like this. I may have one that's going through a tree, but I think you'll get the idea. And we'll get that guy there. And it's really as simple as that. Now, we haven't done anything with distance. We haven't told it anything about what radios to use. Since we left the default, this tool is really geared towards designing for single-family homes like this. Once you have all the connections, except I'm missing one, that guy there. Then the next step is we're just going to run it once. Now there's a couple things. It looks a little cluttered here. I like to turn off the sectors. So what the pi wedges are the different sectors from the base station. So what it's also done now is chosen the base station location, so you can kind of tell those with where you've got something radiating out from them, or where you've got the white circle inside the blue dot. Right. So we've got base stations or access points in a few different places to get the coverage. I like to turn off the pi wedges. What I like to do is actually look at the sectors, and then it makes it a little bit easier to see. There's some advantages to turning on the sectors. If you've got a house that's right on the edge, maybe you can adjust a little bit the placement of the radio and get that house in that same 90-degree sector. Is something else. So it kind of depends on what you're doing, but to me, when I'm looking at one, I find this to be the easiest way to go. And then what we do there, so now if we want to see what the equipment mix is, we simply go out to export. If you want to choose different warranty terms, you can for extended warranty, and then we'll click export, and then we will download it into Excel. And I'll show you what that looks like here in just a second. Let's switch to Excel. And so now you've got a complete bill of materials with the radios. So it gives you, it'll give you radios for whatever you have coverage for. So in this case, we essentially looked at 100% coverage. So you've got the base station radios, the CPE radios, maintenance, and capacity keys for the different radios in that design. All right, so let's jump back to the tool for just a second. All right, close that. All right, so if you remember when we were setting this up, the one thing we did was I made the 80-10 for a longer distance. So let's say I don't have fiber coming down this road, but maybe I have fiber at this water tower. So what we're going to do is go in and just tag that water tower, and we'll still use that house. We're going to do the connection between, actually we're going to tag that as a POP first. Untag that one. And now what we're going to do is go make a connection now between this water tower and that house. We'll rerun the design. You can see now it's got a single point-to-point link. Everything else looks the same. Colors may have changed a little bit, but pretty much the same. And now it's added in. I won't go run the Excel again, but you'll see that it's added in. Actually, I guess I will. It's added in not only antennas for the point-to-point radios, but optics and PoE injectors. 1 second to adjust the Excel. And so now you can see it's added in the point-to-point radios. So it's pretty nice because we don't have to think about part numbers or anything, right? We're just making connections. We know what we want to connect, and even largely we don't even care about how far it is apart, right? We know, within certain distances we want to use the point-to-point, and generally within the neighborhood we want to use the multi-point radios, and then the tool figures out the rest of it for you. So it's really straightforward, and that's really all there is to it. At that point, what I haven't shown you is actually it will generate a channel plan. Let's close this for you as well, so you don't have to worry about that. I mean, at this point, you really do have a deployable solution, knowing which hub homes you want to use, and so forth. Now, let me show you one other thing. Let's do this. We'll do a second segment. We won't finish the whole thing just here in the interest of time. But we'll go back into, let's say we're going to do this part of the neighborhood instead. Let's see how we're going to, whoops, lost my polygon. So a few more houses in this particular area. And these are not tagged for the same reasons before. If I switch back to the road map view, you'll see that they're not there. And so we actually use data from this part of Google Maps to see. So easy enough, as you saw earlier, to fix. I won't go through the effort to fix it right now. But let's say in this case, we wanted to make this this radio the POP. So we're going to delete this link on it. Oops. And now what you can do is actually go do an auto connect. And so now what it does is it goes through and automatically makes all the connections for you. It essentially makes every connection to any other radio. And what you do at this point, I won't actually go through the process of doing it since we're want to leave some time for other questions. What you would actually can do at this point is now go import LiDAR data, and the LiDAR data would actually go and clean all this up automatically for you. So in cases where, so you've got a question, I'll get to in a second, where we clearly go through trees, the LiDAR data will go through and extract all these links that we know are no good. So you can really very quickly get to the point where you can automate virtually the entire process to go create what a network looks like for you in a particular area. So Mike, I'm going to unmute your line. Looks like you might have it maybe muted as well, but go ahead and ask your question.
Yes, I was curious. I might have missed it, but I guess when you're kind of performing the house detection step, is there a particular kind of resolution or zoom level you need to be at for that to function, or how far out can you go? What's kind of the general rule of thumb in terms of
Yeah,
that?
yeah, good question. Actually, let's do this. The answer is no. In fact, if we just selected all that and delete that, I'll delete them. We can just kind of do it again here. So let's zoom out a little bit. Oops, wrong way. So I mean, if you even want, this would be you wouldn't probably do it this high, but even if you wanted to, if you had a bigger neighborhood, for example, and you wanted to do it here. Take a little bit longer than the two since we're doing all of them. So you can have it zoomed pretty far out. You get the same results, right? Just remember these down at the bottom in the roadmap view are not there. So, but yeah, does that answer your question?
Yeah, it does. Yeah, thank you very much.
Sure. All right. Other questions while we're looking at Wendy? Okay, Kevin, hang on one second. Okay, Kevin, go ahead.
So does it automatically detect the trees when you say it deletes them? Does it automatically detect the elevations, the trees, and automatically go around them?
Yeah, when you import the LiDAR data, the LiDAR, basically the LiDAR scan is sort of a topographical scan of the area. And so, yeah, it will, let me switch back here, hang on one second. Let's find this. Actually, let's get rid of this. Hang on. So we're not watching all that stuff go over there. So let's do the same thing again. Here we'll just for grins, we'll make this guy just as an example a pop. We'll go rerun the auto connect. So for example, these connections that are going through these trees, right? When you import the LiDAR data, what you'd see is, I'll do it manually here, is these links disappear. That one maybe is okay, maybe not. Wherever these two clearly are no good, and so I'm manually doing what the LiDAR data would do automatically for you. So you would end up with just imagine get that one. Imagine that process working automatically throughout this one would go away likely as well, depending on the height of that tree relative to the house. And so that's the kind of thing you'd end up with, is all those links that clearly are going through trees or, straight through a house or something like that. The LiDAR data would strip it all out for you. Other questions? Does that answer your question? I assume so. All right. Other questions? All right, well, let's jump back over to the PowerPoint and we'll wrap up here. All right. So, hopefully, whoops, I think I'm not sharing that again. There we go. All right. Oh, actually, before we keep going, Mike, did you have another question?
Yeah, you mentioned, I guess, kind of the LiDAR data. I'm not that familiar. You said that's publicly available information. Is that typically like at a county level, census block level, or how do you access that?
How do you get it? Yeah, good question.
Yeah.
It kind of depends on the state. There are some states, Mississippi is a good example, that have actually, the state has actually done a complete scan of the state. So oftentimes the state has the data that's out there. If there's a particular area that you're interested in, we can certainly help you find that, or and for everyone, if there's a neighborhood or an area that you'd like to take a look at, we're more than happy to go put a design together for you and let you see what it really looks like. But yeah, we're happy if you want to tell me where you are, we can go kind of figure out that if what's available for that particular area and work together with you on that.
Okay. I'll take you up on it. Thanks.
Yeah, sure. Yeah, no problem. All right. Okay. So let's see. I think you can't see my last slide. So, for some reason my screen sharing here is not catching up. All right, maybe we're good here. Yep. Okay, so hopefully, hopefully over the course of the last few minutes, you guys have gotten a sense that, millimeter wave really is a technology that's easy to deploy, easy to design, and really, short of trying to put fiber everywhere, which is a good solution in some cases, but often cases it's a challenging business case, and certainly can have some time challenges associated with deploying. Millimeter wave is a great solution. We've got thousands and thousands of these things deployed all over the world, really. And so, from a reliability perspective, they're solid. We design 4 carriers, 4 operators to begin with, and so they're very robust. They're in some pretty hot and pretty cold parts of the world, and not have any kind of concern whatsoever. So, as I mentioned a minute ago, we're more than happy to work together with you if you have a neighborhood or a Main Street business kind of application that you'd like us to take a look at. Just pop us a note. You're welcome to send me a note. My email address, I think maybe it was on the first slide, but it's easy. It's just todd.l@siclu.com, and we'll be more than happy to help you put a design together. So with that, I'll wrap up the slides here, and happy to take any last questions. All right. Well, very good. Well, if you think of something later, by all means, don't hesitate to pop us a note, and we'll be happy to help you. So thanks for your time this morning, and appreciate the interest. Have a good rest of the week.